Well, hi, good morning. Welcome to my shop. Thank you for being here on July 28th. Starting out sunny, going to change to rain. So what I'm thinking of doing here is rather than continue with the alignment, the shortwave bands are left. I think at this point I'm going to check in with the operation of the radio and use a couple different techniques here to do it. Different than the method I was using to do the alignment, so I'm going to double check with the different method. You might notice the oscilloscope is running back here. That's a bit of a hint of what I'm going to do. So first, let's just, so I can make this fairly easy to understand what I'm up to. I made this diagram in the last video, and I explained that radio can be broken into three parts, right? An RF, IF, and AF part. What I want to do is I want to check this middle part, the IF part. So what I want to do is I want to shove a signal into here, not into the antenna, but right into the start of this box, and then see the result coming out over here to see what it looks like. This might be after detection or before detection. I'm not exactly sure. Now, what I'm going to try to do, sometimes it works great, other times it doesn't work so well. So we'll just hope I can pull this off. So the thing is, I'm not going to feed a steady signal in here. I'm going to feed a sweeping signal. That's a signal that's varying in frequency. Maybe this way is better to show it. Varying in frequency. And that's going to result in a trace on that oscilloscope that is going to represent the response curve. In this case, the response curve of these circuits. And the response curve should look like that. Just like that. And this frequency right here should be 460 kilohertz. That's what we're hoping. If I did the alignment correctly using just the indicating meter, an indicating meter. This time we're actually going to see the shape. And it's not just the shape, it's actually four shapes, one on top of another. 1, 2, 3, 4. These are the two transformers. These represent the two transformers in the IF. So when I was doing the alignment, I'm trying to get the maximum signal out of the radio. By doing that, it causes me to align these four response curves. There they are. You add them all up and you get something like this, if it's working right. Now I haven't drawn this very nice, but you might end up with something that looks like this. Have some weird shape to it. This should be a nice curved shape, just what you might expect. And if it's not, then we're in a position to make fine adjustments of those transformers and really get this thing done correctly. My equipment's still warming up here a little bit. So an oscilloscope has an internal signal that causes the scope to sweep across like this. But in this case, that's not what I'm using. I've turned that feature off on the scope, and instead this sweep is being provided by the sweep generator, which is this guy right here. The sweep generator has been set. I set it before turning on the video. So it's sweeping through the IF frequency range. It's starting, the IF frequency is 460, it's starting at 420 and ending at 500. That should put 460 right in the middle. That should put 460 right in the middle here. That's how this whole thing should work. Okay, now with fingers crossed, I have the scope set. The scope is looking at the same thing, the same output signal, if you like, that the meter was looking at. This meter was looking at. Exactly the same place, right on the volume control. Sometimes this works out, sometimes it doesn't work out quite so well. Let's give it a go. Pretty sure the alignment instructions, they talk about using a scope, and they talk about connecting right there. So let's see how this goes. Okay, I'll get ready to switch on. What's this? This is the other signal generator will probably play a role in a little bit. Okay, everything's ready. Just doing this on the broadcast band. Actually, it won't matter. Or doing the IF doesn't matter. Here we go. Always a little nervous flipping on the on switch here. All looks normal. Oops. Let it warm up. Probably what you're going to hear is a terrible buzz. You may hear nothing because the input signal from the signal generator is pretty low right now. So we'll see what we get. Okay, it's a faint buzz or roar, not the hiss. I'll turn this up, you'll hear it. That's the sound we're looking for. And we're hoping to see a response on here. Somewhere on here. Okay, well, I think we need to give it. I'm going to move you a little closer to the scope here. Okay, we're gonna give it more and more juice here. So that sounded like the radio was overloading. I don't think we're getting any response on here at all. Why is that? Oh, because it's set to ground. That's a dumb move. There we go. Okay, I'll turn the input signal up and down. You can see what's happening. Fair bit of noise in the signal. Try to just identify where the noise is coming from. I'm shorting the antenna input. It's not coming from there. Not to worry about it. It's probably immaterial. Just changing my scope lead input from times 1 to times 10. It's at times 10 right now, but you can see even putting it times 1, it doesn't draw the radio down much. A little wee bit. I can hear it. You probably can't. Tiniest amount. Okay, so that means this is not affecting the radio. Now the question is, let's go back and look at that again. The question is, right at this peak spot, what is the frequency? What is the frequency? Let me just turn down my shop lights a little bit. Maybe I'll turn this up. How can we figure that out? Now I set this up so the sweep is starting in a certain place, ending in a certain place, and in the middle should be something. Now we know. Let's double check all this stuff now. This has been running for a while. Let's stop the sweep. And I'm just gonna, I don't want that bright dot on my scope there. Starting frequency is 415, so I'm going to change it to 420. This is not the easiest to set. It's a very precise signal generator, but it's very hard to set it. So there we are, 420. And now the stop frequency, we want it 500, it's a little low. Okay. Stop frequency 500, start frequency 420. Scan away, please. So we're not in the middle, but are we in the middle? I mean, I can adjust this. So we can never be certain doing this that that's really 460. What I have to do, let me turn the radio down here. What I have to do is I have to bring in another signal generator that I know is providing a 460 signal. Get it to appear on here and see what it looks like. So I'm just going to just parallel in, literally, another signal. So I'm just going to leave this sitting here for a while. I'm going to go drink some coffee, let my other signal generator warm up, and then we will do that and find out if I really got this thing tuned to 460. Because the shape looks perfect. The shape looks perfect. We don't know if it's in the right spot. Okay, here we go with the number 2 signal generator. Now this is just a single frequency, right? 1500, but we don't want 1500. We want 460. So 460, the output is just connected the same place as the output of the other signal generator right here. This is connected to the grid of the mixer tube, which is right in the corner here. That's just a good, convenient spot to clip on right in there. So what I'm going to do now is I'm going to see if we can make this signal generator appear on the oscilloscope. What it will look like is a wiggly spot. So we'll be looking for a wiggly. Now there's all kinds of wiggly spots in here already. So we might have to crank up the power on everything to get this to work. But here we go. Looking for a wiggly spot. Okay, so I've increased the signal strength. Now this is hard to see. You know what? I'm gonna stop and put a better camera on the oscilloscope here. Okay, so you can see I've propped the camera up right in front of the oscilloscope, and here's what we see with that camera. You get a better idea of what's there. Now, let me just make sure the focus is good here as soon as I spot the focus control. This is the actual scope focus. You get a ghostly image of me on top of the screen. It's tricky. Maybe the camera's a wee bit out of focus. Let me just check here. Yeah, that's it. Okay, there we go. Enough of that. So you've been staring at this for a while. I'm going to vary the 460 frequency. That's called a marker generator when you do this kind of stuff, because you're trying to mark a certain frequency. So I'm just going to tune it downwards, and you'll see the squiggle go off to the left. Now it's buried in that noise, so you can't see it very well. It's also suppressed by the radio. Let's bring it around. There's my ghostly head again right above it. So you can see it's kind of gotten right in the middle now. It's like a kind of a balance thing. So this is telling us that the marker generator is right on the same frequency as that dip. If you look over at the marker generator frequency, and what do we see? 460, right on the money. So we got the right frequency, we got the right shape. Not much else to do with the IF. It is properly tuned. Very good. That's very good. I'm very happy with that. Sometimes when I do this, I discover things aren't so well tuned. Fantastic. Okay, so next experiment is going to be, we're going to try to see the front end resonance in the radio, if we can do it. I'm not so sure about that, but we're going to try. Okay, here we go for this test. First, we are going to continue with the oscilloscope for just a bit. What I've done now is I've transferred the signal input from part way in the radio, from sticking it in here to sticking it right into the antenna, and I'm now sending into the antenna the full range of AM radio station frequencies. So it's starting at around 500 kilohertz, and then it's sweeping up in frequency all the way up to 1700, and then reverting back and going through again. It's doing this very fast, by the way. I didn't mention that. It's sweeping, I think 1,000 times. It's a 10 millisecond pass. 10 milliseconds to do this. It's like 100 times a second. It's sweeping through there. Sounds like this. That's what it sounds like. I'll stop the sweep. Stop the sound. Good. Okay, we're not making use of this signal generator. I'm just gonna, it's not connected to anything, it's just sitting over there. Now, what's the idea with this? I'm gonna show you the oscilloscope. What exactly are we seeing there? So we have to think about this. The sound we're hearing and the little blip here represent the moment when the input frequency on the antenna passes where the radio is tuned. So right now the radio is tuned to 700. So conceivably this is 700 right here. Now if I tune the radio, that should move around. There it goes. Now it's changing size and that because there's an AVC action that's affecting it. It'll tune up. top of the band, there's a thunderous pounding coming out of that speaker. Just like really low. So what this is proving to me is that what's it proving? My setup is valid for the next test. Okay, we don't need to listen to that. Now the next test involves something crazy here. I'm going to try something, yeah, actually crazy. So let me put on the screen my SDR radio. Here we go. Well, it took a bit of fiddling around to get this sorted out, but this is what we need to see. Now, what are we looking at? So if you'll see the word medium wave here, and it's a little hard to see, but there's a blue band. You see the blue band ends right here. This blue band is marking the broadcast band, which is disappearing off to the right. So this is 1,000,000 or 1,000 kilocycles. It's a local station here from Toronto called 1010. That's just will be located right here. So it's kind of like the tuning dial of the radio, if you like. And this is the bottom end. And there's 550, 600. So 640 would be, that's probably 640 right there. Could that be 640? Let's listen to it for a second. No, that's not 640 because it's 620. I don't think we can hear any stations the way I have this set up. No, we can't. That's good. We don't really want to hear this. It's looking at this. Now, you're probably wondering what the heck is going on over here. So this gargantuan signal, which is shown on the SDR this way, is the local oscillator of the radio. And the frequency is I would say there. Let's say 1030. 1030. So if you subtract, you know what, I'm going to make it 1060. I can make this easy on me. I'm going to raise this up to 60. Doing this to make the arithmetic easy. I'm going to retune the radio and watch that peak move. Okay, and we'll move it right up. This is a super strong signal here, by the way. Why it's jumping up and down probably has more to do with the reception of the signal than the radio itself. I don't think the radio is going up and down like that. Something to do with my hand position too. So there we are. So now the local oscillator is at 1060. If you subtract 460 from that, you get 600. The radio should be tuned to 600. Now what am I gonna do? 600. I need to prove it's tuned to 600. So I'm gonna switch off that this view. How do I know the radio is tuned to 600? It has a sweep generator going through it, so we're gonna always hear that sound as the sweep passes the tune point of the radio. It's literally going thump, 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 but it's doing it so fast. Sounds like that. It did jump a bit. Still got a little bit of trouble in the volume control. Okay, how are we going to know for sure that everything is working right? We know the IF frequency is 460. We know that. So we know that if the local oscillator is running at 1060, the radio will be sensitive at 600. I'm going to prove that. I got to prove that. I just need to prove these things. Prove these things to me. So we're going to try to make it. Well, what we can do is we can stop the sweep. There's a good idea. We'll stop the sweep. Turn up the volume. And we're going to give it a 600 here. Feed it in here. Okay, so you should be watching this guy here. 600. Now my frequency counter is a little low all the time, so in fact this is probably 599 here. There you are, 600. Good. reduce this and remove it. Actually, I don't need it now. Just proving things to be the way they should be. Things are as they appear. Now we'll go back to the SDR radio and find something very, very interesting on it. Now we won't find it. What happened here? Oh, I know what's happened. We retuned the radio a bit, didn't we? No, it's on 600. Oh, the sweep is off. Okay, sweep on, sweep on. Whoops, volume down. Now, did you notice something pop up when I turned it on? Did you notice this? This guy right here. This little bump here is the tuning on the front end of the radio. Remember I showed you the three parts to a radio. The left, the middle, and the right. The left side, the RF side, is tuned. And it's tuned to the frequency of interest. The frequency of interest right now is 600. We have the local oscillator set for the radio to put a 600 kilohertz signal, or shift it to 460 and have it come out the speaker. Now, if the radio was poorly aligned, when we have it tuned to 600, this peak might be down here or up here. So what's really happening here is we're kind of rejecting away all the signals that are not 600. And so what around 600, I shouldn't say 600, everything has a curve to it. So nothing is so sharp that the radio can't just receive 600 precisely. There's always a bandwidth involved in it. So now what we're going to do is we're going to retune the radio up to the top end, and we're going to find out where this ends up and what happens to it. I'm going to shift this whole display to the left, just far enough that we can still see this bump. This guy is so gigantic, eh? So I'm going to tune the radio. As I do, this will move up, and this should move up with it. And you may see other signals running around in here. Ignore them. That's what I would recommend. We're going to tune it up to 1500. Well, can I get to 1300 on here? Okay, I'm going to tighten up the display a little bit. Maybe that's a mistake. Maybe, so you can still see the little peak here. We're going to travel up to 1500. We're going to move the local oscillator to 1500. This thing should move. Let's see, if I tune up to 15, say I go to 1560, then this thing should be peaking at 11. 11 will be here. Okay, so I'm going to go to 1560. We're going to tune in 1560 here. We're going to do it based on the dial indication on the radio. Okay, so I'm doing that now. 15. I said 1560. Well, that's a little hard to be dead on. I think that's 1560 there. Could be a little off. If it's 1560 that I've tuned it to, the local oscillator should be 460 above that. So if you add 1560 and 460, what do you get? You get like you get 20, I don't know. I can't add in my head anymore. Okay, let me write this down. Make a mistake here could lead to a lot of nonsense. Once again, radio is tuned to 1560 or so. If we add 460 to that, can you hear me scratching away on a piece of paper here? 2020 is what the local oscillator should be. 2020. Hey, it's 2022. 2020. So we'll measure it here. I'll just go like this. This is a great thing about the SDR. Get it right on? I think that's pretty well right on. 2025. Well, that could be simply because I can't tune the radio accurately. Let me make sure the local oscillator is where it should be. Okay, I'm going to move it to where the red line is. Okay, the radio is now, regardless of what it says on the front dial, the radio is ready to receive what? 1560. 1560, 2020, 2020, yeah, 1560. So now we look for that little peak, which might be quite hard to spot now. So So 1560 will be right in here. Look at all this noise we got to work through. How are we going to see it? So I'm going to tune the radio back and forth and see if we can't see the little peak. But I have the feeling it's going to be almost impossible to see. Here we go. Back and forth a bit. Now, to see there's other things moving, so we need to look for something moving at the same rate as the local oscillator. I got my hand on the control, so I kind of have the edge on this. I don't see it anywhere. Let's go way down so we can find it. So there it is. So right now it's around 1100. You can see it there. Now it's going up. 1200. 1300. Ooh. I lost track of it. 1300. It looks. Oh, it's really hard to spot here. So that thing I'm pointing out with my finger, which you cannot see, is not it. I got to go back down and find it again. So you can see the upper end doesn't see there's a pretty strong peak down here around a million right now. Right where my finger is that you can't see. Right at a million. So that's the front end tuning. Well, how good is it there? So if the radio's tuned to a million, the local oscillator should be 1,460,000. That's easy arithmetic. There we are, 1,460,000. It's right on. So you see the radio alignment is very good here. So it's good at the bottom, good in the middle. It's going to be good at the top too. Well, how high up can we go and still see that thing clearly? So we really know where it is. Things are a little tough right around here. So I can set it to 13. So I'm trying to put that front end peak on 13. I'd say that's roughly it there. It's not a very good test at this point. So it's around 13, and if you add 460, you get 1760. So the radio should be tuned to the impossible frequency of 1760, 1768. So I mean, within the range of my ability to do this. So most stations we can get here in this area of Ontario or Canada or down in this area, lower frequencies, and it's working really well down there. All these other things, all these other peaks, probably noise in my shop, from the computer, from the two screens I've got going, from little wall warts that are plugged in here and there, and who knows what else is doing it. That's good. So this is proving that the alignment of the AM radio is really pretty good. You can see the whole time that dip was on the scope there. It's hard to see in the camera there. Good. What does this mean? This means we're good to go. I double checked the IF, which is pretty important. I've checked the front end of the AM reception. Shortwave not nearly as critical as the AM reception. You saw how small that thing was that the front end tuning was moving around. Well, in shortwave it's kind of like this. I think you can think of it that way. Could be wrong about that. We can try the same test too on shortwave. But I think the situation is we're ready to align the shortwave bands, and that's just about the end of it for the radio. But I think that's all I'm going to do today. Is this. This is good enough. We got some sunshine this morning I can enjoy, and then rain coming later. So I think I gotta go out. Feel the sun. Feel our star. Okay, so thanks a lot for watching, and check out tomorrow what happens. See ya.